Good evening, everyone. This is again your teacher for the subject, Engineer Gideon G. Bunyel. And our topic for this day is all about fundamentals of electricity and electronics. So we will learn more about electricity and electronics. Okay. Now, first things first, we go to the history of electricity. A brief history of electricity. From Benjamin Franklin to Tesla Motors. So this is the history. When we flip on a switch, we get electricity instantly and our lights turn on. Almost like magic, but behind this everyday convenience of life is a rich and varied history. It has been a journey of almost 270 years and counting ever since electricity was discovered by Benjamin Franklin. So si Benjamin Franklin is the one who discovered the electricity first. To the modern inventions we have today, from electric cars, zooming around to computers being charged by light or Li-Fi technology. Okay. Discovery of electricity by Benjamin Franklin. In 1752, Benjamin Franklin ran his famous kite experiment. So if you've ever remember the kite kite experiment, so it was Benjamin Franklin who performed that type of experiment. Okay? Now, as a prominent American scientist and one of America's founding fathers, Franklin tied a key to a kite string during a thunderstorm and proved that static electricity and lightning were one and the same thing. Okay? Following this historic result, people were eager to try to harness the power of electricity. So it was Benjamin Franklin through his kite experiment that static electricity and lighting were one. So they concluded that one. And that was the first time that people are eager to discover more about electricity and how to harness it, how to use the electricity as what we are experiencing right now. For the primary goal of lighting their homes in a cheap and safe way instead of oil and gas lamps, which were flammable and dangerous. That's why few years back, especially in 1752, our the people there or our ancestors use oil and gas lamps. So I even experienced using oil and gas lamps, which is very flammable and dangerous, right? Even when we use candle, it's very dangerous. Fast forward to 1831, Michael Faraday realized that an electric current could be produced by passing a magnet through a copper wire. So it's more about not of the copper wire. This amazing discovery formed the bedrock of today's electricity and how we generate it through magnets and coils of copper wires in big power plants. So if you have seen even in our motorcycles, it uses electromagnetism. Only that it runs using the diesel or gasoline. Because of this principle, both the electric motor where electricity is converted into motion and the generator where motion is converted into electricity were born. So because of this concept, electricity is converted into motion and motion is converted into electricity. So more like vice versa. Thomas Edison, the invention of the light bulb. If you're familiar with Thomas Edison, so he was the one who invented the light bulb, okay? As one of the greatest inventors who ever lived, Thomas Edison began working on electricity and brought to life in 1879 the world's first incandescent electric light bulb. If you're familiar with incandescent electric light bulb and you're also familiar with what to call that, incubator for the egg. So usually the lights that used for incubators are incandescent lights because it heats faster and it creates more temperature. Okay, the yellow warm light or the yellow warm light that you always see, and that till today is still being used. As a result of this invention, the entire gas lighting industry was made obsolete and Edison began to create his own company. So, nawaya na ang gas as a source of like light because it was replaced now by electricity through the invention of Thomas Edison, the light bulb. Thomas Edison began to create his own company to manufacture and distribute his light bulb invention to every corner of America. So it was Thomas Edison's time. The world's first modern power grid. While electricity could be generated and transported, it had to be used the moment it was consumed as storage. Even till this day, it's very costly and has limited utility. Samuel Insull saw an opportunity in the early 1900s to bring together mass efficiencies in production and consumption. He consolidated all the smaller generators and chose to generate electricity by bigger and more efficient generators manufactured by General Electric. So that is GE. If you're familiar with the brand GE, I think this was the first one, General Electric. A shift to alternative and renewable energies as the decade continued to roll by, most of the electricity generation was done using fossil fuels. Okay? From the word fossil fuels, from coal to fuel oil. However, with these traditional methods of electricity generation came an increase in carbon footprint and the emission of greenhouse gases. So, using this, it actually hurts the environment and of course it creates greenhouse gases which damages the ozone layer of the earth. The world began to focus on renewable energy. Okay, from the term renewables, so such as wind power and hydropower. So in Ilocos, they have wind power, if you're familiar with that, and hydropower in Maria Cristina Falls. Okay, that's hydropower. Both of which were in the use since the early 1900s. But it was only in the early 1930s with the construction of the Hoover Dam. Okay, we're complete now. And the construction of the Hoover Dam when hydropower really took flight, and in the 1950s for wind power once the first utility grid connected with turbine became a reality. So we're complete now. So we're in perfect attendance. So to those who just came in, we are now talking about the history of electricity. Well, now let's go to Tesla Motors, electric cars, and batteries. As we move towards 2020, with the new breakthroughs happening every year, electricity is being harnessed in ways few could have imagined. Take Tesla, for example. The company has revolutionized the way we drive by inventing their electric car series, which boast long travel distances, a smooth and quiet ride, as well as free electricity recharge at any of their charging stations. If you're familiar with Tesla, this feature focuses on driverless, but as I've said in our previous topics, cars should be driven by people and not be automated. So it's just a guide for the drivers. And now Tesla, if you have Tesla cars nowadays, so they have free electricity recharge at any of their charging stations. In addition, Tesla is also beginning to make electricity storage feasible and cost-effective for the average family home. With their Powerwall series, families can store electricity and power from the grid that can be used later during outages to help keep the lights and the air conditioner running and the fridge cool. So when we talk about electricity savings, so mostly we use now solar panels that can store energy and electricity and can be used later on. So that's one example. Now, let's also tackle about the history of electronics and some of the most famous people that we can actually encounter. Okay. Brief history of electronics and their development. In the 21st century, every day we are dealing with electronic circuits and devices in some of other forms because gadgets, home appliances, computers, transport systems, cell phones, cameras, TV, etc., all have electronic components and devices. Today's world of electronic has made deep inroads in several areas such as healthcare, medical diagnosis, automobiles, industries, electronics, projects, etc., and convince everyone that without electronics, it is really impossible to work. So electronics in our everyday lives, we use electronics like for our laptops, for example, our computers. So there are um, PCB boards inside it that is composed with the different electronic parts. Okay, so that's therefore, looking forward to knowing the past and about the brief history of electronic is necessary to revive our minds and to get inspired by those individuals who sacrificed their lives by engaging themselves in such amazing discoveries and inventions that cost everything for them but nothing for us. So our ancestors gave all their efforts for the discovery of these electronics devices, electronics concepts that cost them a lot of like time, resources, but for us it's nothing. And in turn benefited us immensely since then. So we are the ones who benefited from these discoveries. Electronics actual history began with the invention of vacuum diode by J.A. Fleming in 1897, and after that, a vacuum triode was implemented by Lee D. Forrest to amplify electrical signals. This led to the introduction of tetrode and pentode tubes that dominated the world until World War II. So these are the example. Subsequently, the transistor era began with the junction transistor invention in 1948. Even though this particular invention got a Nobel Prize, yet it was later replaced with bulky vacuum tube that would consume high power for its operation. The use of germanium and silicon semiconductor materials made these transistors gain popularity and wide acceptance usage in different electronic circuits. The image on the right side is what we see is the integrated circuit or IC. So we usually see this to our different electronic components, electronic devices at our homes. Okay? The subsequent years witnessed the invention of the integrated circuits. I've seen, as you said earlier, this one, that drastically changed the electronic circuit's nature as the entire electronic circuit got integrated on a single chip, which resulted in low cost, size, and weight electronic devices. The years 1958 to 1975 marked the introduction of IC with enlarged capabilities of over several thousand components on a single chip, such as small scale integration, medium, large scale, and very large scale integration of IC. So there were different sizes for these ICs. Okay, is still there, Judy,
Yes, sir.
Jack, Ryan, Marvin.
Yes, sir.
Okay, okay. Nice, Ryan. Okay, let's proceed. And the trend further carried forward with the GFETs and MOSFETs that were developed from 1951 to 1958 by improving the device designing process and by making more reliable and powerful transistors. So these were the times that ICs were developed properly, and there were already revisions and improvement as regarding to these ICs. Digital integrated circuits were yet another robust IC development that changed the overall architecture of computers. These ICs were developed with transistor logic or TTL, integrated injection logic I2L, and emitter coupled logic ECL technology. So these were the technologies using the transistors during that time in integrated circuits as well. Later, these digital ICs employed PMOS, InMOS, CMOS fabrication design technology. So one of the most familiar is the CMOS, which we can also find in our PC or personal computers system unit. Okay. All these radical changes in all these components led to the introduction of microprocessors. So I've explained in our subject, the previous subjects of all about microprocessors in 1969. Imagine in 1969, they already started the microprocessor by Intel. So Intel is one of those first to discover microprocessor. Soon after, the analog integrated circuits were developed that introduced an operational amplifier for analog signal processing. So there were integrated circuits that can amplify analog signal. These analog circuits include analog multipliers, ADC and DAC converters or analog to digital converters, and DAC is digital to analog converters and analog filters. This is all about the fundamental understanding of electronics history. This history of electronics technology caused a greater investment of time, efforts, and talent from the real heroes. Some of them are described below. So let's meet also some of the heroes for this electronics. So we can have an idea as to who they are and their contributions in electronics aspect. So we have Luigi Galvani, was a professor at the University of Bologna. He studied the effects of electricity on animals, so especially on frogs. With the help of experiments, he showed that the presence of electricity in frogs in the year 1791. Imagine, he studied the frogs during that time. We also have Charles Coulomb. Charles Coulomb was a great scientist of the 18th century. He experimented with mechanical resistance and developed the Coulomb's law of electrostatic charges in the year 1799. When we talk about electricity, Charles Coulomb will always be mentioned because we have unit in electricity in Coulomb, named after his name. So we have also Alessandro Volta. So in Philippines, Volta is a superhero. So in electronics also, um, Alessandro Volta was an Italian scientist and also a hero in electronics field. He invented the battery in the year 1799. So imagine, it was Alessandro Volta who invented the battery in the year 1799. He was the first to develop a battery volcanic cell that could produce electricity as a result of a chemical reaction. So we have batteries of vapes, the one that you use is a battery. Batteries for our motorcycles, our cars. So it was Alessandro Volta who discovered and invented it. We also have Hans Christian Orsted. Hans Christian Orsted showed that whenever a current flows through a conductor, a magnetic field is associated with it. He initiated the study of electromagnetism and discovered aluminum in the year 1820. So if we talk about Hans Christian Orsted, you just remember that electromagnetism word and then discovery of aluminum is because of Hans Christian Orsted. George Simon Ohm. So this is one of the most famous in the field. George Simon Ohm was a German physicist. He experimented with the electrical circuits and made his own part, including the wire. He found that some conductors work when compared to others. He discovered Ohm's law. That's why we have Ohm's law now in the year 1827, which is a relation between current, voltage, and resistance, that we will be learning later on. So we will talk about also the Ohm's law. The unit for resistance is named after him. So that's why the unit for resistance, we have 10 ohms, 10 kilo ohms. Okay, it's all about ohms. Michael Faraday was a British scientist and a great pioneer experimenter in electricity and magnetism. After the discovery by Orsted, he demonstrated electromagnetic induction in the year 1831. This is the basic principle of the working generator. Samuel Finley Breeze Morse brought a telegraphy system to the forefront with electromagnets and invented the code in 1844 and named after him. So if you're familiar with Morse code, right? It was Samuel Finley Breeze Morse. So that's why it's named after him, the Morse code. Joseph Henry was an American scientist and independently discovered the electromagnetic induction. In the year 1831, a year before Faraday's discovery, the unit of induction was named after him. So that's why Henry is the unit for unit for induction. Okay. Heinrich F. Elens was born in Tartu, the old university city, Estonia. He worked as a professor at St. Petersburg University. He followed several experiments on the lead of Faraday. Hermann Ludwig Ferdinand von Helmholtz. Hermann Ludwig Ferdinand von Helmholtz was a universal scientist as well as a researcher. In the 19th century, he is one of the famous scientists. We have also in the year 1879 rather, Joseph Wilson's one was invented as an electric lamp in Britain. The filament of the lamp is carbon and had a fractional vacuum, and demonstration of preceded Edison's in 6 months. We have also James Clerk Maxwell. James Clerk Maxwell was a British physicist and he wrote a treatise on magnetism and electricity in the year 1873. Si Sir William Crooks. Sir William Crooks was developed electrical discharges using Crookes tubes. So from the terms Crookes tubes, so if you've encountered these words, it was Sir William Crooks, which are highly evacuated in 1878. We have Oliver Heaviside. Oliver Heaviside worked with the equation of Maxwell to decrease the exhaustion incurred in resolving them. In the procedure, he created a vector analysis form known as operational calculus. This one of the famous also, Heinrich Rudolf Hertz was the first scientist to demonstrate the radio wave's existence. His motivation came from Helmholtz and Maxwell. In the year 1887, he demonstrated the velocity of radio waves and also known as Hertzian waves, which were equivalent to that of light. The frequency unit, like Hertz, is named after him. That's why we have the frequency is named after Hertz. Like for radio station, they have indicated hertz, how many hertz, megahertz for the radio stations. So it was named after Heinrich Rudolf Hertz. Okay, sure, you're now familiar with it. Charles Proteus Steinmetz. Charles Proteus Steinmetz was discovered the mathematics for hysteresis laws, therefore allowing engineers to decrease magnetic laws within transformers. So magnetic laws within transformers was discovered by Charles Proteus Steinmetz. Ben Franklin invented different electrostatic generators by rotary glass balls for the experiment. By using this experiment, he invented the electricity theory for the single fluids. It was Ben Franklin. Now, also one of the familiar, we have André-Marie Ampère. André-Marie Ampère was a French mathematician and physicist. He studied the effects of electric current and invented solenoid. So invented solenoid was André-Marie Ampère. The SI unit of electric current, the ampere, was named after him. So that's why the unit for electric current now is ampere. Like we have for our electrical devices at house, like 2 amperes, 3 amperes, our power banks. If you want fast charger power banks, it should have a 2 amperes USB slot because most of the power banks nowadays has only 1 ampere. So if you want to go for fast charging, so it should be minimum of 2 amperes. So that's one trivia. We have Carl Friedrich Gauss was a physical scientist and the greatest German mathematician. He contributed to many fields like algebra, analysis, statistics, and electrostatics, and astronomy. The CGS unit of magnetic field density was named after him. Okay? Still there?
Yes, sir.
Very good. Very good. Still on. Hans, kuha na si Kuhan. Now, let's go to Wilhelm Edward Weber. Wilhelm Edward Weber was a German physicist. He investigated terrestrial magnetism with his friend Carl Friedrich. He devised an electromagnetic telegraph in the year 1833 and also established a system of absolute electrical units. And the MKS unit of flux was named after Weber. So for flux, it was named after Weber. So that's the unit. So if you were going to encounter this one, then that's the one. Okay. Thomas Alva Edison was a businessman and American inventor. He developed many devices like practical electric bulbs, motion picture cameras, photographs, and other such things. While inventing the electric lamp, he observed the Edison's effect. Okay. Now, let's go to Nikola Tesla. If you're familiar with this one, I'm sure you're very, because this is one of the most famous also. He invented the Tesla coil, the Tesla induction motor, alternating current or AC, the ones that found in our homes, so that's AC, electrical supply system that includes a transformer. Imagine three-phase electricity and motor. In 1981, the Tesla coil was invented and used in electronic equipment, television, and radio sets. The magnetic field density was named after him. So basically, when we talk about history of electricity, it will be always associated with Nikola Tesla, and there are a lot of conspiracy theories because of this. We have Gustav Robert Kirchhoff, was a German physicist. He developed Kirchhoff's law that allows calculation of the voltages, currents, and resistance of electrical networks. So for those involved in electrical engineering or electrical studies, so Kirchhoff's law, voltage law is very well associated. We have James Prescott Joule. James Prescott Joule was a brewer and an English physicist. He discovered the law of conservation of energy, so it was Joule. The unit of energy, Joule, was named in his honor. So that's why the unit for energy is Joule. To develop the scale of temperature, he worked with Lord Kelvin. Sir John Ambrose Fleming, the earliest diode tube was invented by Sir John Ambrose Fleming in 1905. Okay, for Lee D. Forrest, Lee D. Forrest was an American inventor and invented the first triode vacuum tube. Albert Einstein, of course, even though we always known him for the general theory of relativity and survival of the fittest in biology, Albert Einstein in the year 1905, Einstein was involved in Max Planck's experimental results to notice magnetic energy appeared to be produced from radiating objects within quantities that were separate. The power of these emitted quantities is known as light quanta, and it was directly proportional to the radiation frequency. Here, this frequency was different from standard electromagnetic theory depending on Maxwell equation as well as thermodynamics law. Well, Albert Einstein is not only about the biology, physics, but also involved in electronics and its development. Walter Schutzky was a German physicist. He defined shot noise random electron noise in thermionic tubes and invented the multiple grid vacuum tube. Howard Armstrong was an inventor and American electrical engineer. He invented electronic oscillator and regenerative feedback. So it was Armstrong for oscillator, if you're familiar with it. In 1917, he invented the super heterodyne radio and patented the FM radio in the year 1933. So it was Edwin Howard Armstrong that patented the FM radio that we have now in our time. Jack St. Clair Kilby was invented the IC integrated circuit at Texas Instruments. Robert Norton Noyes. Robert was implemented the IC using a practical approach for scaling the circuit size. Seymour Cray in the year 1970, the father of supercomputers, namely Seymour Cray and George Amdahl, was defined as the industry of supercomputers. So imagine, we have now supercomputers by that time. The Ray Prasad, the author of the Surface Mount Technology Principles and Practice textbook is Ray Prasad. Now, since the lead engineer, he initiated SMT into airplanes as well as security systems at Boeing. He handled the SMT global implementation like a program at Intel organization. From 2000 to 2009, the timeline of electronic history is listed below. In the year 2006, the former World War II as well as PS3 gaming console were invented. So 2006, we all have already PS3. In 2007, the first Apple iPhone as well as iPad were invented. Again, 2006, PS3, 2007, first Apple and iPad. In 2008, the first Android operating system for smartphone was invented in the year 2008 also. The Large Hadron Collider was invented. In the year 2010, Xbox 360 was invented. So, mas una ka si PS3. In the year 2011, the revolutions of the solar panel like renewable energy source as an alternative energy source. It was 2011 for the solar panels. In the year 2011, the space vehicle was invented by NASA. The landed on Mars. 2014, microscale 3D printing was launched. 2018, NASA launched the Parker Solar Probe. In the year 2019, the Chandrayaan 2 was launched by India to the moon. So let's have a break first. 5 minutes break. Or you can go to your CRs. Okay, let's have a break first. 5 minutes. So we'll resume at 7:13. Can we now continue our discussion?
Okay ra, sir.
Jack?
Pwede ra, sir.
Okay. Good, good. Grabe. Ayan. Okay, let's proceed with the discussion. Now we go to so there again there were a lot of names that I have mentioned earlier. I know that you cannot just grasp it effectively or in that instant, but when I give to you this presentation later on in a PDF file, you can just read those names and be familiarized with it because those names are the foundation of what we have right now in electricity and electronics. Now we proceed with conductor, semiconductor, and insulator. What is the difference between conductors, semiconductors, and insulators? The main difference between the conductor, semiconductor, and insulator is in its condition state. The conductor, from the word conduct, always conduct electric current, while the insulators do not conduct. However, semiconductor conducts and blocks at different conditions. Okay? So for the conductors, like for example, that's why we get electrocuted because like our body is a good conductor also. When we put a metal and connect it with our extension wire, of course, we will get electrocuted because metals are good conductor. And for insulator, the that I can um, relate to you is the rubber. So rubber is a very good insulator for electric currents. What is a conductor in electrical and electronics engineering? A conductor is a type of material that allows the flow of charge, otherwise known as electrical current. Most electrical conductors are made from metal. So electrical conductors are made from metals. Okay, Amara, that's what we need to understand and try to remember. Semiconductors are materials that have conductivity in between conductors and insulators. That's why it's called semiconductors because it has its properties between the conductors and insulators. Okay, they can block or allow the current flow, providing total control over it. They are mostly modified by adding impurities called doping. Okay. What is an insulator? An insulator is a material that has very high electrical resistance. So as I've said earlier, rubber is one type and it does not allow the flow of current. There are no free electrons in insulator, thus they do not conduct electricity. Okay? That's why our pliers, the handle is coated with rubbers because rubbers, as I've said, is a very good insulator. Voltage, current, and resistance and Ohm's law. So we are now on this topic. When beginning to explore the world of electricity and electronics, it is vital to start by understanding the basic of voltage, current, and resistance. Amo ini ang pinaka-importante sa aspect na electricity sa electronics. Okay? These are the three basic building blocks required to manipulate and utilize electricity. At first, these concepts can be difficult to understand because we cannot see them. One cannot see with the naked eye the energy flowing through a wire or the voltage of a battery sitting on a table. So, just for your information, this is how George's Ohm looks like. So, that's why we have now Ohm's law. So, electricity is the movement of electrons. Electrons create charge, which we can harness to do work. Your light bulb, your stereo, your phone, etc. are all harnessing the movement of the electrons in order to do work. They all operate using the same basic power source, the movement of electrons. If we dig deeper, it will always be associated with neutrons, electrons, protons at a nucleus level. So that's actually the if we dig deeper of the electricities and we can learn those things and it touches already the part of the chemistry of this electricity. The three basic principles for this tutorial can be explained using electrons or more specifically the charge they create. Okay, voltage is the difference in charge between 2 points. Current is the rate at which charge is flowing. So flow from the term flowing, so that's the current. Resistance is a material's tendency to resist the flow of current. So from the word resistance, so it's the tendency to resist the flow of current. So let's proceed. So when we talk about these values, we're really describing the movement of charge and thus the behavior of electrons. A circuit is a closed loop that allows charge to move from one place to another. Components in the circuit allows us to control this charge and use it to do work. Again, from the picture that I've shown you earlier, George Ohm was a Bavarian scientist who studied electricity. Ohm starts by describing a unit of resistance that is defined by current and voltage. So let's start with voltage and go from there, okay? So we define voltage as the amount of potential energy between 2 points on a circuit. One point has more charge than the other. This difference in charge between 2 points is called voltage. It is measured in volts from the term voltage, which technically is the potential energy difference between 2 points that will impart on joule of energy per coulomb of charge that passes through it. Okay? The unit volt is named after the Italian physicist Alessandro Volta, who invented what is considered the first chemical battery. Voltage is represented in equation and schematics by the letter V. So voltage is represented by letter V. When describing voltage, current and resistance, a common analogy is a water tank. In this analogy, charge is represented, okay? So if we put this on analogy, charge is represented by the water, okay? Water amount. Voltage is represented by the water pressure. And current is represented by the water flow. Okay, for this analogy, remember, water, charge, pressure, voltage, flow, current. Consider a water tank at a certain height above the ground. At the bottom of this tank, there is a hose. Okay, so voltage is represented by this one. So the pressure on this one is the voltage. So from the term pressure, voltage. Okay, so that represents our voltage. The pressure at the end of the hose can represent voltage. The water in the tank represents charge. So the water here represent the charge. Okay, and the pressure, overall pressure in here is the voltage. The more water in the tank, the higher the charge. Okay, more water, higher charge. The more pressure is measured at the end of the house. So more water in tank, higher the charge, and more pressure at the end of the hose. So for the current, it represented by this one. So average, we have here the more and the less. We measure the same amount of pressure at the end of either hose. But when the water begins to flow, the flow rate of the water in the tank with the narrower hose will be less. Okay, so of course, because since this is narrower, so the flow becomes lesser also compared to this one. So that's why it's indicated here more and the other one is less. In electrical terms, the current through the narrower hose is less than the current through the wider hose. If we want the flow to be the same through both hoses, we have to increase the amount of water or charge in the tank with the narrower hose. So just increase here the charge here inside this one to make it equivalent to this one. Okay? We measure the same amount of pressure at the end of either hose, but when the water begins to flow, the flow rate of the water in the tank with the narrower hose will be less than the flow rate of the water in the tank with the wider hose. In electrical terms, the current through the narrower hose, atong gamay, is less than the current through the wider hose. So that's why ito dako siya. If we want to flow to be the same through both hoses, we have to increase the amount of charge in the tank, okay? Let's go to resistance. So resistance is indicated by this diagram here or the image that you can see. So less resistance, more resistance, okay? And the difference, as you can see, the difference between the two is this is wider, and here for the more resistance, so it has a narrower part. In electrical terms, this is represented by two circuits with equal voltages and different resistance. The circuit with the higher resistance will allow less charge to, so more resistance, less charge to flow. So that's why it's narrower because it's more, the resistance is more. But in terms of the charge, it's less because the area here is narrower. This brings us back to George Ohm. Ohm defines the unit of resistance of 1 ohm at the resistance between 2 points in a conductor. So let's proceed to mga important na things. So if you're familiar with Ohm's law, guys, this is like pinaka-important na siguro sa part na ini nato pag-calculate. So Ohm's law is V is equals to IR. Okay? Remember this one ha. V is equals to IR. This is the formula to compute the voltage, the current, and the resistance, okay, in a circuit. So V voltage in volts, okay? The I here is current in amps. And the R is resistance in ohms. So voltage, the unit for voltage is volts. The unit for current is amps or ampere. And the R resistance, the unit for this one is ohms. Okay. This is called Ohm's law. Let's say, for example, that we have a circuit with a potential of 1 volt and a current of 1 amp and the resistance of 1 ohm. Using Ohm's law, we can say that 1 volt is equals to 1 ampere times 1 ohms. Okay? Let's say this represents our tank with a wide hose. The amount of water in the tank is defined as 1 volt and the narrowness, resistance of flow of those hose is defined as 1 ohm. Using Ohm's law, this gives us flow current of 1 amp. Using this analogy, let's now look at the tank with the narrow hose because the hose is narrower, its resistance flow is higher. So that means it's inversely proportional. If hose is narrower, then resistance flow is higher. Let's define this resistance as 2 ohms. The amount of water in the tank is the same as the other tank. So using Ohm's law, our equation for the tank with the narrow hose is 1 volt is equals to question mark ampere times 2 ohms. So if we calculate ampere, so we transpose 2 ohms here. So that becomes 1 volt over 2 ohms is equals to the ampere, okay? But what is current? Because the resistance is greater and the voltage is the same. That's why here, if we calculate for the amperes, if I have here no? Activities. Okay. Let's just make use of this one. So 1 volt is equals for the question mark ampere and the 2 ohms. So since this is the general formula to get the ampere, since this is what we want to get, we just transpose this 2 amperes. So the amperes that we're looking for is equal to 1 volt over 2 ohms. So that is 0.5 amperes. Okay? Now, because the resistance is greater and the voltage is the same, that this gives us a current value of 0.5 amperes. So that's why 1 over 2 is 0.5. So this was the amperes that we're looking for. So just remember that one, ha? So the current is lower in the tank with higher resistance. So again, lower current, higher resistance. Okay, inversely proportional man sila, okay? Lower current, higher resistance. So, that's why matranspose na nato si si resistance sa PCAS. Now we can see that if we know two of the values for Ohm's law, we can solve for the third. So for example, that's why if ever given ang volts and an amperes, we can now solve for the resistance. If ang given is amperes and ohms, then we can solve for the voltage. And on the other hand, if it's the given is voltage and amperes, then we can solve already for the ohms. Okay, nakuha niyo ang concept. Did you remember guys na volts for the Ohm's law, volts is equals to current times resistance. So V is equal to IR. Okay, remember na dyan na kay para mag-compute you lost your network connection. Can you see my Kwan? This diagram here.
Yes,
Nawaya
sir.
ako kay nagkuan. Ako internet mo ganing fluctuate kadali. Okay? So this is example of a circuit. So if we have lamp here, like for example, the battery is our source. If we have switch, of course, if it's turned on, the lamp will turn on as well. If it's turned off, the lamp will not turn on. If you can see this, once we click the switch, it will tap here and it will close the connection. That's why we see that the lamp will turn on. Now, flashlight as an electric circuit. If you're familiar, of course, we are all familiar with flashlight, right? The flashlight is a simple device that incorporates all three of these components. The two batteries in the flashlight are the source. The light bulb at the end of the flashlight is the device into which the current flows. Current flows through a very tiny filament which heats up to a very high temperature of the electrical resistance. As a result, the filament glows brightly. So, this is now the example, okay? So, for our flashlights, di ba? We have flashlights in our home. When we put battery, that's already the source. Okay? Then we have the switch to turn it on. Once it's turned on again, the light bulb will light up. Then, of course, before it goes to the bulb, it will travel to the wire. And we have here represented by the positive and negative. Okay? For batteries, it should not be interchanged for DC voltage. If the sign says positive, then you connect the positive there. Okay? Flashlights are most other electrical appliances also have a switch. A switch is merely a device that helps to break the continuous loop of the conducting material. Actually, guys, the main concept lang for electric circuit is if this is closed, dili gid siya mo kuryente. Like for example, electric fence, um, there are live electric fence, but they're also dependent on the ground. If you hold the electric fence, you will not be for your rubber boots. But if you touch the ground, then that's the time that it will have, even in the circuit
Choppy ka, sir. Choppy ka, sir.
plug
Sir, choppy ka.
into the wall
Sir, potol-potol ka, sir.
Sir, choppy ka,
all
sir.
Chapi.
wala ako internet. Check. Diyan na? Check.
Diyan na, sir.
Okay. Bear with me ra kay this quite kuan natural laman tapuson. Okay. Clear na no?
Yes, sir.
Okay. A fuse or a circuit breaker is used to prevent major fires due to overloads. That's why we have fuses in our homes, di ba? Circuit breakers also help because when it detects overflow of current, it will automatically plug down the circuit breaker, which prevents from major fires or overloads. A fuse is designed to burn up if the current gets too high. So fuse, if it detects that the current is more than the allowable within the fuse, so it will burn up. So it will not be useful anymore. There are two types of circuits found in homes and other common devices, namely series circuits and parallel circuits. So we just have to remember this, series circuits and parallel circuits. So nawaya man ako, no? Hello, guys?
Okay na, sir. Kaya may presentation, sir.
Ibalik
Um, ako ano ko.